Maxine Levin, for being here to support our webinar and introduce our presenter. Maxine, I'm going to turn the webinar over to you so you can introduce the topic and our presenter.
Okay, thank you so much, Sean. I want to first start out by giving a description. This is Marie T. Orosz, and she's from the Army Corps of Engineers. And about, I'd say, 3 months ago, I got a call from the state conservationist in Maryland asking if I would be willing to host an individual who's doing a leadership development program, not with the NRCS, but with the Army Corps of Engineers and actually DOD. And I enthusiastically, once I saw the resume, said, yes, I want to do this. And I had a project in mind specifically that I had been wondering how I might get to do and get going. And there it was, an individual with an engineering geology background who might know quite a bit about this subject, and if they didn't, they would have the opportunity to learn. And so Maria T. Orosz accepted our proposal because she had many proposals for details for a developmental assignment, and she accepted ours, which was to work with the Soil Science Division interpretation staff in looking at the effect of intense burns on hydrophobicity of soils and the effect onto debris flows. And she'll be talking about that as well as her developmental assignment. We had interactions from the engineering staff and discovered that there are a lot of folks that have an interest in this subject, as well as just the intensity of the catastrophic events that have been happening in California, but are now happening in other parts of the country, and so this subject will continue to be something of interest to us in the future. So I'm going to give it over to Maria now and have her start her presentation, and I welcome folks afterwards to ask questions both about the topic and about her executive leadership program, which I found to be quite interesting and perhaps something that we might, as the NRCS, be interested in the future. So thank you, and Maria, go ahead.
Okay. Well, thank you, Maxine. Good morning, everyone. Thank you for joining in on the webinar. I'm just going to pass through the first title slide. So just to give you guys some background about what I do in my current job and what I've been doing here with the U.S. Army Corps of Engineers for the past 13 years. I've moved from a field geologist working behind drill rigs, taking soil and rock core samples, to a project manager, to becoming the chief of the geology and investigation section within Geotechnical Branch of Engineering Division at the U.S. Army Corps of Engineers in the Baltimore district. So I know several people that I've spoken to over the past 8 weeks have had some interactions with the Corps of Engineers, but I think they have been mostly with another division, which would be our planning division, if you've interacted with any of the Corps offices, I guess, across the nation. So this was a little bit of a departure for me as well, because we don't normally interact with anybody from the NRCS within engineering division. So a part of my duties as the chief of the geology and investigation section is that I oversee office geologists as well as the field geologists, and I oversee our drilling unit and our Geotechnical Materials Laboratory. So our drilling unit is one of 7 or 8 units nationwide across the Corps of Engineers that are placed throughout the nation. We work on doing drilling for foundation design. We do install like monitoring devices on dams or within levees, so mostly on federal properties. And so that's what some of these pictures are on the slide, are pictures of our drill rig. They're at Fort Drum, the bottom left. The middle one is we're at Chickamauga Lock in Tennessee, and that's the upper right one. And then the building is a picture of our material and instrumentation unit for the geotech lab at Fort McHenry here in Baltimore. And then that bottom right picture is beyond doing geotechnical laboratory testing. The lab also does routine pipe inspections using robotic cameras to ensure that drainage piping around our dams and levees are clear and free, and if they are having obstructions, then we can send that camera in those drainage areas to see what the blockage is or what may be the cause for some blockages in the drainage areas. We've also used that camera to inspect piping underneath a runway on one of the air bases. So it's pretty multifunctional. And then as far as my staff here at the office, they do mostly environmental work, like the soil groundwater remediation, and soil groundwater remediation, geophysical investigations, mostly on cleanup on military installations themselves. So moving on to the actual program that I'm in. So the Executive Leadership Program is offered through DoD, so it includes federal agencies within that. And so there were actually several people from the USDA that were involved with the program, one of which was on my project team. And when I asked him, how did you become a part of it, he basically just said his boss invited him to attend. And so for myself, it was an actual formal application process where I had to submit my application to our headquarters in DC, and then they selected 3 people from however many they had received to participate. So a brief description of the program is that it's a 9-month program for federal employees targeting GS-11 to GS-13. They use a mixture of individual assignments and team assignments, and then they also do some individual assessments to determine your MBTI, your conflict management style, and combined with that knowledge, then that also helps you work through your competencies that you may have to further develop. So as you can see under the requirements, there's multiple requirements throughout the 9-month program that do include individual and team. So I had to do 5 executive interviews, a shadowing assignment, and then the major part of that was the 8-week developmental assignment to which I'm currently on with the NRCS. So just a few specifics about the developmental assignment. So it's there to help develop the competencies outside the technical or my technical expertise. So when I was in graduate school at Baylor, I did my thesis on soil, so it was something that I was always interested in, and thought that this would be a good opportunity to kind of explore that curiosity in that from my thesis. So again, practice skills and learnings from a different work environment, contribute to the workforce. And then as far as what my expectations were from the NRCS, just basically become familiar with the agency, interact with other leaders, managers, personnel, which I had a great opportunity attending the Geomorphology Institute, going out to Lincoln and sitting in on the basic conservation course, and just that ability to interact with the students and the trainers to really get an overall perspective on what the NRCS has to offer training-wise relative to the Corps, simply because we don't have any 3-week courses, so I thought that was interesting. And then just focus on the developmental competencies, and the 3 that were identified for me were resilience, team building, and then influencing and negotiating. So I am an introvert, and so at times it can be difficult for me to communicate with others in an uncomfortable environment. So the ability to be able to go out to the Geomorphology Institute, go out to Lincoln and interact with folks in different buildings and agencies has really helped me with working on being more extroverted. So in working with Maxine on what my special project would be, aside from working on those developmental competencies, we discussed the special project of the use of soil properties using GSERGO to predict post-wildfire effects on debris flows, runoff, and other land erosion processes. This has kind of evolved from when I first started 8 weeks ago. I gave a lunch and learn presentation in Lincoln, and we had focused more on hydrophobicity, which is still an element of this, but with talking to some folks that I'll name later on in the presentation, we've kind of been able to more specify or get a better direction as to where we wanted to go with the special project. So just a little background, and we had contacted someone named Trevor Coe from, I believe, CalFire, and he had kind of guided us in the direction of about 4 or 5 papers to kind of narrow down our focus. And so this Moody paper from 2013 identifies the #1 priority for further research relative to debris flows and burn intensity as being a focus on the engineering soil properties. So within that paper, it listed these, soil water content, hydraulic properties, physical changes, soil erodibility parameters, as being that. So we really wanted to target the soil parameters and properties based on this paper. And then a few of the other papers that we had read, we had noticed, I'd read that, had noticed that they used STATSCO data, which is my understanding is that it combines fewer map units than the GSERGO data. You get a broader, more general perspective of the soil, and the intent with using the GSERGO database was to have a more robust data set. And then from there, I had also contacted some folks in the Forest Service to focus on burn intensity related to the soil properties. So the initial analysis would be since there seemed to be a lot of data for the Cedar Fire and the Thomas Fire, the decision was made to kind of narrow our focus to the engineering properties specifically for these fires in California, given the database. So again, we really wanted to focus on burn intensity, debris flow risk, and then from the GSERGO data, pull the hydrologic group, and then another paper that I had read targeted specific engineering soil properties. So there's several, but this paper identified the following 5 soil properties. So that was kind of the focus for the initial comparison between the risk of debris flows and these soil properties, just to see if there was any overlap between burn intensity, debris flow areas, and these engineering soil properties. And then in addition, when we were bringing up the idea to the interpretations group, Kathy Siebold mentioned that she was working on, it's not an unpublished version of the susceptibility to soil surface sealing. So because that's tied to hydrophobicity, we believe that it would be good to include that in with this preliminary research. Not to mention that it was also mentioned in a paper by Larson, which is quoted there at the bottom of the slide. So we thought that was a good tie-in as well. So what is soil surface sealing? Basically, the depiction kind of follows through with the wording. It's the orientation and packing of dispersed soil particles, and then the physical breakup of the aggregates from the raindrops, and then with the high severity fire, it increases the runoff and sediment yield. And so essentially this data, these parameters are pulled from the NASA's database, and we've created, and Kathy was able to create a layer to kind of depict the soil surface sealing. And I see there was a question, so I neglected to mention that both the fires were targeted in California. So a part of the premise and the original thought for this idea came from, the more recent fires that are occurring in California, and there's an increased level of interest and research that's been ongoing in California, and this was to kind of carry along with the current research that's being conducted. So with the surface soil sealing, so when you get those layers around the particles, that can also contribute to the hydrophobicity, which may be referred to as soil water repellency. And so this is a great depiction of how during a more intense fire, you can see that the water repellent layer, the duff, so in an unburned forest, it's a thin layer usually at the top of the soil, composed of organic matter and duff. And then in burned forests, it actually vaporizes and goes from high to low. So it's going to want to go deeper into the soil. So it goes down the temperature gradient further on in the soil. Again, this is still, it kind of goes along with the soil surface sealing and the hydrophobicity, and just looking to how much of a factor that has to do with the erosional processes during the debris flow. So just some preliminary findings. So this is the cedar fire out in California. For the purposes of this presentation, we're only going to depict the cedar fire. So you can kind of see the debris flow risk here. The debris flow risk for the liquid limit. The debris flow, the high-risk debris flow are the hatched areas. And then the areas that we identified during the cedar fire, again, we had a layer that showed the low to high-risk areas for debris flows. The hatching are the debris flows, and then the liquid limit, you can see the more red areas have a lower liquid limit, which is indicative of, less clay, less silt, so more of a sandy material. And then moving to the next slide, the upper left slide shows the soil susceptibility for surface sealing, and then the one in the upper right is the debris flow relative to the organic matter. So I was hoping that there would be maybe a higher area of soil susceptibility underneath the hatching within the debris flow. But unfortunately, in this particular area for the Sierra fire, it looks like it was all considered low based on that initial analysis. And then for the organic matter, it looks like the organic matter is higher, so we would expect that in a much more forested area, so that's kind of coincident with that. But these are just kind of some of the initial figures that we would be putting together along with some tables in the future to kind of compare the data and the layers and see if there's overlap between, ideally we'd like to overlap all these maps underneath the debris flow area and see if there's any consistencies beneath that high-risk area that we could predict the soil properties. So applications and implications. So the application is to use pre-fire soil properties to predict post-fire soil effects. So it could be from a large to small scale, and again, the preliminary focus is just in California, but the idea is that if there are consistencies, then we may be able to apply this throughout the U.S. Where there's been high intensity burn. In addition to the application, it also has policy implications for evacuation. So if a soil is more or less, if homeowners' properties are located in areas that are identified based on the findings for a high susceptibility to a debris flow, then maybe they would be evacuated first, and then you could also look into folks that are within a potential debris flow path area and kind of put out the warnings and see who would have the primary evacuations or where they would be on the evacuation list. I just wanted to include this slide to just kind of show debris flow basins and some of the means that, man-made means that they're putting in to kind of collect these debris flows in areas that are down gradient from these burn areas. So this is just a picture of an actual debris flow basin that has some material in it. It's my understanding that the NRCS does have these on a much smaller scale already out in California. And then I just included the list of contributors to some of the folks that we had reached out to and their emails. And so even beyond this preliminary assessment, these folks we'd be contacting again. And then again, just the list of references that were initially used for this preliminary finding. And I think that's it for the presentation.
I just wanted to add, thank you so much, Maria. I also wanted to add that Maria has created a briefing paper that the Soil Science Division interpretation staff and the national engineering staff will be working with to create perhaps even a more formal briefing paper for higher leadership in thinking through our next steps for both research and applications. One of the references down there at the bottom, the USDA NRCS 2016 Hydrology Technical Note number 4, hydrologic analysis of post-wildfire conditions. The engineering staff is planning to do further studies, particularly with the areas of the wildfires in California, most recent. And there are also thoughts of applying this information other parts of the country. For instance, just in the last couple of weeks, there's been some intense fires in agricultural land in Oklahoma, and so we'll be looking at those areas too as we move forward. In addition, Maria is creating a poster just to describe her work that she did with this preliminary work, mostly for discussion at the Western Regional National Cooperative Soil Survey Conference that's going to be in Tucson in a couple of weeks. So that's it. Thank you. Thank everyone so much. Sean,
I do have a couple of questions.
Okay, let's go.
So the first one is from Alan. He says, where was the Cedar fire?
Maria, you go.
Yeah, so both fires we targeted in the California region. So it was in California. I honestly...
I can be a little more clear. The Cedar fire is pretty much northwest of San Diego. Or, no, northeast of San Diego, in the foothills. The Thomas fire, which is the major fire that made all the news in 2017 and early 2018 in the Ventura County area, was where was surrounding the debris flows that were deadly, the deadly debris flows in Montecito, California, just outside of Ojai. We have staff that were actually affected by those fires and were evacuated, part of the evacuation for those fires, and then also part of the evacuations later on associated with potential debris flow activity. So we have folks right in that area of Area 2, California, who are directly affected and are very interested in continuing this work.
All right, our next one is more of a comment from Leslie Devers, and she doesn't have a way to communicate verbally with us, but she says she is very interested in seeing the briefing paper, and thanks you for the presentation. It was very interesting. And there is a question from Richard Christie. How is ESP a factor or soil characteristic relevant to fire and hydrophobic layers in the soil? So ESP would be exchangeable sodium percentage.
I didn't really look at that, so I don't know, Maxine, if you can help me out with that question.
Well, that's a factor that we haven't explored, but if we're looking at burn intensity numbers and looking at these analyses throughout the country, we will need to address that factor. And so I appreciate you pointing that out, and we will consider that as we move forward in these studies. It wasn't a factor at all in the Cedar fire or the Thomas fire, but it is possible if we move into areas like Arizona, even Oklahoma, parts of the Midwest, northern Midwest, we might actually have some of that we need to consider.
Okay, he was thinking it was a factor in one of the slides.
Mm-hmm.
All right, and Richard's come back and said, okay. Any other questions out there? And Alan asked the question, are there any plans to develop a scientific team to work on a soil slippage mass movement potential and incorporate into an interpretation?
Yes. The briefing paper was part of that, and we've started to collect folks that are really, really interested, and if you would contact me, I'll put you on the list of interested parties, but of course we're going to move far and wide to try to find interested folks. The list of contacts that was the previous slide from the references, if you wanted to go back, Maria, back to that slide.
The contributors?
Go up one slide to the contributors.
Okay.
To the contributors. These are some of the real subject matter experts throughout the country. Most of them reside with USGS and now with CalFire and the Forest Service and Colorado State University. It happens, something that we discovered in our research, that we have an old graduate student from Colorado State, the original professor, Dr. Lee McDonald, who has written a lot of the major work in this subject. Zamir Lovahova, one of the research scientists at this National Soil Survey Center in Lincoln, did his master's degree with Lee and has expressed an interest in working with us too. So, and he did his master's specifically on this subject.
And Richard Christie was following up. He says, I think slide 5 or 6 had ESP on it, but no big thing.
Yes, it did.
And Wiley asked the question, can you re-explain slide on fire burn and wet layer in soil?
Could you repeat that question?
Can you re-explain the slide on fire burn and wet layer in soil?
Okay.
That's the one.
Yeah, Maria, you want to talk a little more about that?
So essentially when we were first looking at hydrophobicity in the soil, it was related back to like a duff or organic layer on the soil surface. And so it creates this like impermeable, semi-impermeable layer, and it's usually comprised of like a waxy type material given off from like the duff or pine needles, let's say, from that material. And so in an unburned area in a forest, it sits on the surface, and water kind of infiltrates around it, and it allows the water to completely, like, I guess it allows the water to slowly infiltrate if it's on the surface. But the problem is that whenever a burn happens, that duff and waxy layer kind of melts and creates this impermeable layer that usually gets shifted down. It melts like down into the particles within the soil and creates this water repellent layer. And so that water repellent layer will kind of sit at the surface, and then without more like a higher burn intensity, that layer will continue to shift downward into the soil column toward a lower temperature gradient. And so you could have a hydrophobic layer in a higher burn intensity area at a lower depth. And so the idea is that any soil above that hydrophobic layer with increased rainfall would then just erode off that layer of soil above that hydrophobic layer.
Maria, you might point out also, let's see, it's the fifth particular illustration right there. Often with really high intensity fires where there's a lot of heat, the waxy material or the resins volatilize, but instead of going up, they often go down with increasing temperature down into the soil. That's been the general assumption. And that also, if it gets fairly low, then there's a potential wettable layer above that could move with a high liquid limit quickly and be more erosive for getting things started in a debris flow. At least that's been the assumptions from literature in the past and with many of the fires. Something that was pointed out to us as we worked with the subject matter experts is that the folks working on the bear fires, the bear intensity teams, that's BAER, and most of those are Forest Service people that come in after a fire to test the burn intensity and to map the burn intensity, and they are looking for that water repellent zone. And what they've seen, particularly in CalFire folks, what they've seen is that it appears, at least right after the fire, spotty of the fires that they've seen. This doesn't mean it might not be significant, but it's hard to pinpoint the significance in a map. And then it's also an ephemeral feature where it is potential after a couple years that it'll disappear or dissipate over time.
So Alan just has, just check it and make sure you understand. So the burned organic matter clogs the soil pores in the mineral soil. Is this correct?
You want me to answer that, Maria?
Please, sorry. Maxine?
Yeah, so that's partially correct. It could be at the surface. It could be in the subsoil collecting within the pores, where it where it's volatilized and it moves with decreasing in temperature down and then crystallizes or hardens again in the pores to create that hydrophobic system.
Well, Maria and Maxine, that has exhausted all of our questions. I want to thank you both for your time and effort to make this presentation, and thanks to all the participants for joining in. We had more than 50 people join today's webinar. The on-demand recording of this webinar will be available on our National Soil Survey Center YouTube channel within a few days, so feel free to let your colleagues know about this training opportunity, and this concludes our webinar presentation.